Hi, thank you for joining me in my final year project video. My project is an NLP project, looking into installing personality into dialogue systems by response type tendency control. Firstly, what is response type tendency? To begin with, we talk about response types. We believe that every response in a conversation can be classified into several different categories. Classifications can be done mainly based on purpose and sometimes tone as well. See these examples on the screen. These types are what we call response types. In dialogues, the tendencies of a person producing certain types of responses are called response type tendencies in this project, or RTTs for short. And RT refers to response types. Now with this definition in mind, we proceed to the core of this project. This project is built upon a key finding from previous research on the relationship between personality and RTTs. People of different personalities speak with different RTTs during conversation, and by varying the RTT of a dialogue system, the personality displayed by this dialogue system also changes. This project verified this finding again by integrating some of the experiments done by previous studies. The innovation of this project, however, is to use this finding to infuse personality for dialogue systems based on large language models. We intend to use RTT control to make dialogue systems display different personality traits known as DS-RTTs, dialogue system with response type tendency control. This can be extremely useful in industries where personality control for chatbots are important, like customer service chatbots that needs to stay friendly and chatbots in games that need to speak with the personality of characters. So we move on to the next part, where I introduce you the 3 steps for response type tendency control. In this project, we first define a list of response types. We used these response types as labels and labeled utterances of different fictional characters from a text corpus we constructed. We then obtained RTTs of characters by taking the aggregated probability. Finally, we group the characters by personality traits and extract the RTT vectors for different personality traits. Let us jump into the first step. Before this project, a number of studies have been carried out on RT, or referred to as intent in some studies. A few RT lists have been proposed. We performed an evaluation on them and discovered problems. We proposed our own RT list for this project. We edited existing definitions, and as this project intends to use dialogues from fictional work, we referenced linguistic studies on RTs that exist in common conversation and examined the text corpus of fictional dialogues in order to add additional RTs to our list for better coverage. Here is our proposed RT list in this project. We defined a total of 11 RTs, among which 3 have their definitions edited compared to studies that propose them, and 3 new RTs are added. Now that we have identified the RT list, it is time we proceed to the second step, obtaining RTT from characters. We constructed our text corpus from Arknights, a mobile game with many unique characters, and the IMSDB database, where movie scripts can be found. We then decided on the characters to pick from. Here are 2 criteria that we used to select characters. First, the characters should have different personalities. We referenced online database to check their personalities and made the character pool as diverse as possible. We also checked that they have enough utterances in dialogues. Most of the characters we selected have significant appearance in the plot. Here is a summary of the characters we picked and related facts about the dataset we extracted. We took 16 characters from Arknights that covered 9 MBTI personality types. As we noticed that there does not exist characters that are curious, we added 2 characters from IMSDB movie scripts that are ranked as the most curious characters online. As we can see from the chart, the size of the dataset is sufficient for us to work with. Next, we talk about how we obtain RTT from characters. We trained an auto-classifier to help us label the utterances from the text corpus. The RT classifier is trained with a dataset we constructed with sentence generation by ChatGPT and manual touch-up. We used Roberta pre-trained model from Hugging Face Transformers to train the classifier, and it performed decently on our test subset. Here are the RTTs obtained for the 18 characters. The final step is to extract RTT vectors for personalities. We first need to re-examine the characters and score them on the 6 personality traits, as can be seen on the left of the screen. We did manual evaluation of trait scores for characters by volunteers, and take the RTT of the top 6 scores and bottom 6 scores for trait high and trait low, and aggregate for an average RTT vector for a trait. The final RTT vectors for the 12 different personality trait types are shown above. The highlighted portions are RTTs that are of statistical significance with the high-low of the trait. With RTT vectors for different personalities, we need to construct a dialogue system based on an LLM with the vectors. We use GPT-3 to construct the dialogue system. We first went on to prompt engineering to make sure that the model is producing what we wanted, as GPT-3 is a prompt-driven model. We started by controlled experiments on requesting responses of only one type for conversations, and then going on to ask it to generate a random type from multiple types. The later attempt did not go well, so we resorted to an external script. The final pipeline of DS-RTT can be seen here. When human input is received, it is appended to the conversation history H. In the meantime, a random number is generated. The number is used with RTT vector T to select the correct prompt for the corresponding type. Prompt P, along with a base prompt BP and the conversation history H, form the complete prompt, which is then sent to GPT-3 to retrieve a response. The response is displayed to the user and also recorded in H for the next round of conversation. We also conducted an evaluation on DS-RTT to assess its effectiveness in personality control. We choose our baseline to be dialogue systems from the same model, with the prompt set to those that describe personalities. We observed two problems, drifting and overfitting, where the problem started with introvert responses but went on to become an extrovert later. Or it overfits into the personality by only producing a few types of responses, which degrades the conversation experience. For DS-RTT, we observed through manual evaluation that drifting is solved, as type control is done explicitly. Overfitting is also somewhat mitigated, as even extrovert low people have sometimes that they use longer expressions. However, we still observe some overfitting in conversation, as the dialogue system responded with type of responses that are not normal options in most human conversations, even for those personalities. Here is an evaluation result on the personality for DS-RTT. We can see that DS-RTT outperforms or at least equals the baseline in 9 out of 12 personalities, which means it is more effective than the baseline method and our approach is meaningful. Those 3 red fields, future work needs to be conducted to improve it. That marks the end of my FYP video. Thank you very much for watching, and I hope that my video has interested you and convinced you the innovativeness and value of this project.